Hello friends, welcome back to Be Pharmawise. Today we are going to discuss a very important topic which is nucleophilic substitution reactions. As you know, this question is asked for 10 marks in your final university exam, so you need to prepare it well and you should know what are nucleophilic substitution reactions, what are their different types and what is the mechanism which is followed through this nucleophilic substitution reactions, what are the differences between different types of them. So in this video, I am going to cover all of this in detail, but before starting the video, I would like to request you all to please take a moment and hit that red button, subscribe button and the notification bell in front of it so that you will be notified whenever I post a new video, and I keep on sharing such content related to pharmacy syllabus periodically. So you must please subscribe to my channel, and without further delay now, let's get started with the video. So friends, we will start with the discussion of what are substitution reactions. See, substitution reactions are the reactions in which an atom or group of atom is replaced by another atom or group of atom, but the condition is the initial atom which is getting replaced should be directly attached to carbon. So I will take an example and we will learn this. See, this is a basic organic molecule, you know this is methane. Now methane when reacts with chlorine in presence of UV light, what happens? One of the hydrogens of methane get replaced by chlorine atom and you end up getting methyl chloride plus HCl. So if you can see the reaction carefully, the hydrogen which was directly attached to carbon is replaced by another atom which is chlorine. So this kind of reactions are called as substitution reaction. Let me take one more example. Suppose CH3 CH3H Br. Suppose this is the compound and which when reacted with aqueous NaOH, what happens? This bromine atom which is directly attached to carbon is replaced by OH and you will get CH3 CCH3HOH and NaBr. So as you can see, this kind of reactions involve the replacement of an atom or a group of atom which is directly attached to carbon by another atom or group of atoms. So such reactions are called as substitution reactions. Now substitution reactions can be initiated by various reagents. For example, they can be initiated by a nucleophile which is electron rich species. Then they can be initiated by an electrophile which is electron deficient species, or they can even be initiated by free radicals. If the substitution reactions are initiated by a nucleophile, such reactions are called as nucleophilic substitution reactions. Whenever they are initiated by electrophile, they will be termed as electrophilic substitution reactions, and here they will be called as free radical substitution reaction. My entire focus will be on nucleophilic substitution reactions today. So we are going to discuss nucleophilic substitution in detail. So friends, now let's start with the nucleophilic substitution reaction. I will write here two types of nucleophilic substitution, SN1 and SN2, and we will discuss how these types are made. See, first you observe how it is written. It is written S, then N capital, but it is written below S, means as a subscript, and then 1 I have written. Similarly, I have written SN2. Now what does it mean? S refers for substitution, N refers to nucleophilic, and 1 refers to unimolecular. Unimolecular nucleophilic substitution reactions are referred as SN1 reactions. Similarly, 2 is referred as bimolecular. So bimolecular nucleophilic substitution reactions are referred as SN2 reactions. Now how or on which basis this is named or this is referred to? 1 means unimolecular unimolecular means it is a first order reaction where the rate of reaction is directly proportional to only one component of the reaction, and which is the substrate in the reaction. Now what is substrate? The molecule on which you are carrying out the reaction, the molecule on which the reagent is attacking, that is called a substrate. Okay, the rate of reaction is directly proportional to only the concentration of substrate. Then this will be called as a unimolecular nucleophilic substitution. Similarly, here the rate of chemical reaction will be proportional to by means 2. So it is a second order reaction, and the rate will be dependent on concentration of not only the substrate but also the reagent, and here the reagent is none other than your nucleophile. So if the rate of reaction is directly proportional to concentration of substrate as well as the reagent, which is nucleophile, then the reaction falls under SN2 reaction mechanism. So this is the basic difference between SN1 and SN2. It is unimolecular nucleophilic substitution, which is a first order reaction where rate is directly proportional to concentration of substrate, and it is bimolecular nucleophilic substitution, which is a second order reaction where rate will be directly proportional to concentration of substrate as well as the concentration of nucleophile. So now we will discuss one by one all these types in detail. Now friends, we will start with the discussion of SN2 reaction mechanism first. So for discussing SN2 mechanism, I will take an example of hydrolysis of methyl bromide in presence of aqueous NaOH or KOH, and what will happen, bromine will be replaced by OH and you will get CH3OH plus NaBr. So as you can see, this is a plain substitution reaction which follows second order kinetics. It is a bimolecular nucleophilic substitution. Now we will find out how and what is the exact mechanism. So I will write the molecule of CH3Br. Now as you know, carbon is attached to 4 different atoms in methyl bromide. So carbon is in its sp3 hybridized state. Now in sp3 hybridized state, carbon has tetrahedral geometry. So in tetrahedral geometry, it looks like this. Now who is the reagent? NaOH is the reagent, means who is the nucleophile? OH minus is the nucleophile. Now this nucleophile has to attack on the substrate. Now first look at the molecule, substrate molecule. You will find out the carbon-bromine bond is a highly polar bond because of the difference in electronegativities. Bromine is a halogen atom and it is having higher electronegativity than carbon. So automatically it will acquire partial negative charge and carbon will be partially positive, means it is electron deficient. So now when OH minus looks at the substrate molecule, it immediately finds its target, which is this electron deficient carbon. Now OH minus has to attack on this electron deficient carbon, but this side there is bromine. So if OH minus tries to attack from this side where bromine is attached, there will be electronic repulsions because OH minus is electron rich and bromine is also electron rich. So the attack from the side where bromine is attached is not possible. So now what it will do? It will go backside and it will attack from the opposite side from where the bromine is attached, and this is called as backside attack of nucleophile. Now when the OH minus comes and attacks from the backside of this carbon, then what happens? Now carbon and OH hydroxyl ion, they are in a process of forming a new bond, and this carbon and bromine now are in a process of cleaving or breaking the existing bond. So now this takes the molecule in a very unstable state, which is called as transition state. Now what happens in transition state is, this OH minus has come for forming a bond with carbon. It has not yet formed completely, so I have shown partial arrow. Then here bromine is in a process of breaking the bond with carbon. Now what happens? These 3 hydrogens which were attached to carbon, now they rearrange themselves so that all 3 CH bonds lie in a single plane. See, this is a single plane, and in the single plane all 3 CH bonds lie, and on perpendicular to that plane, on one side there is OH bond, on other side there is bromine. Okay, now CBr bond is about to break. Now bromine will not leaving behind the electrons. It will leave as a bromide ion. Means, see this bond, CBr bond, it is a covalent bond. Means one electron was given by carbon, one electron by bromine. Now bromine is leaving as bromide ion. So if it is leaving as bromide ion, it is taking away both the electrons with it. Okay, that is when it can leave as a bromide, and now both the electrons for formation of COH bonds will be given by the oxygen. The oxygen has the lone pair which will be utilized for formation of this bond, and then it will lead to formation of COH bond, which is again a sigma bond, a covalent bond, and then the hydrogens will again rearrange themselves, so that the carbon will again acquire the tetrahedral geometry, because now carbon is attached to 4 groups. It is in sp3 hybridized state, so it will again go back to tetrahedral stage. So this planar hydrogens will now shift themselves so that to acquire the molecule a much more stability or stable configuration. If you look at the initial molecule, the substrate one, bromine was attached to right hand side. Now if you look at the product molecule, OH is attached to left hand side. So this is like complete inversion of configuration of molecule, and this complete inversion, 100% inversion of configuration is referred as Walden inversion. So in SN2 mechanism there will be 100% inversion of configuration of molecule, which is also referred as Walden inversion. So this is the mechanism of SN2 reaction. So here it is a bimolecular reaction. See, the rate determining step, it is only a one step reaction. So in this rate determining step, both the substrate as well as the concentration of nucleophile will play the role to determine the rate of reaction. If your nucleophile is not strong enough, the reaction will not proceed with a good rate. So for having a good rate of reaction, it depends on both the substrate as well as a nucleophile. It is a one step reaction. So more stronger your nucleophile, more faster your reaction be. Okay, so this is how the SN2 reaction mechanism is done. Now we will discuss the SN1 reaction mechanism. Now let's discuss the SN1 reaction mechanism. So for SN1, I will take an example of hydrolysis of tertiary butyl bromide, CH3, 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 Br. It is tertiary butyl bromide, and it when reacts with aqueous NaOH, it gives formation of, it leads to formation of tertiary butyl alcohol plus NaBr. Now let's discuss the mechanism for this reaction. You know that OH has replaced bromine to produce tertiary alcohol. Now we will discuss the mechanism for the same. Now this mechanism is not a one step mechanism. It is unimolecular reaction, means the rate is only dependent on the concentration of substrate, and this reaction follows a two-step mechanism. In step number 1, the ionization of tertiary butyl bromide takes place. So this is your tertiary butyl bromide. Again it is sp3 hybridized, so it is having tetrahedral geometry. Now this molecule undergoes ionization. So what will form? This carbon will be positive and bromine will be negative because of the high electronegativity of bromine atom. So you will get a bromide ion minus, and you will get CH3, CH3, CH3 plus. This is a carbonium ion. Now you must be wondering why I have shifted the geometry, because when carbon is attached to 3 groups of atoms, it is in sp2 hybridized state, and sp2 hybridized state has trigonal planar geometry. So this carbonium ion is planar. It all 3 CC bonds are in one plane. Okay, so this is the first step. Formation of carbonium ion from the tertiary butyl bromide is the first step. Now in a second step, this this carbonium ion, I will write it here, step 2, this is the planar carbonium ion which is there. Now in step 2 what happens, this OH minus, which is your nucleophile from the reagent, it comes and attacks on this carbonium ion. Now look at the carbonium ion, it is a planar ion. Carbon is here, CH3, 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 all of them are lying in one plane. So when OH minus comes for attack on the positively charged carbon, it has equal probability to either attack from this side or from this side. So OH minus can attack from either sides. If it attacks from this side, what will happen? OH will be attached here and you will get this molecule CH. And if it gets attached to right hand side, you will get this molecule OH and here 3 methyl groups. So you can see there is 50% inversion of configuration and there is 50% retention of configuration. These are the stereochemical aspects of SN1 reaction mechanism. Key, the OH minus has equal probability of attacking the carbonium ion from either sides. So it will lead to formation of 50% inverted product and 50% retention of configuration will be there. So this is how SN1 mechanism is followed. So just understand one very important point here, कि why tertiary alkyl halides undergo SN1 reaction mechanism and why don't they prefer SN2? Because in SN2 we have taken example of methyl bromide, right? Hydrogens are very small in size. So it is possible for OH minus ion to reach the carbon for backside attack. But here you see the structure of the molecule, 3 methyl groups are attached towards these 3 sides of carbon. So OH minus do not find enough space to reach this carbon. So it is very difficult for OH minus to go and attack from backside on the carbon. So SN2 mechanism is not possible for tertiary alkyl halides. So they go by a safer side, they first ionize their tertiary butyl bromide to reach this carbonium ion. Now it becomes very easy for the nucleophile to attack on the carbonium ion. This is the reason even if your nucleophile is weak, SN1 reaction is possible. If your nucleophile is weak, if the concentration of nucleophile is low, SN2 reaction is not possible because there the role of nucleophile is to invade the molecule to reach to the carbon. Here in SN1 reaction, already a carbonium ion is provided ready-made for attack by the nucleophile. So weak bases can be okay for SN1 reactions, but for SN2 reaction mechanisms you need to use stronger bases. Okay, so this is the first difference between SN1 and SN2. Now we will discuss what is the case with secondary alkyl halides. You must be curious na ki okay, primary alkyl halides will preferably undergo SN2 reaction mechanism, tertiary alkyl halides will preferably undergo SN1 reaction mechanism. Why, you have understood, but what about secondary? Secondary falls in between. So the mechanism by which secondary alkyl halides undergo the reaction, nucleophilic substitution, will be determined by presence of solvents. Now how? Suppose if ionizing solvents are present in the medium, if polar solvents are present in the medium, they will have the tendency to polarize the molecule to give the ions. Carbonium ions will be generated. So when carbonium ion is ready-made, SN1 path will be followed, right? But if non-polar solvents are present, if the solvent is not playing any role with the ionization, if it is not assisting with the ionization of the substrate, then SN2 mechanism will be preferred. So now let's discuss the differences between SN1 and SN2. So I will write SN1 here and I will write SN2 here and we will study the differences. The first difference is this reaction is unimolecular and here it is bimolecular. This is the first obvious difference. Second obvious difference is it is a first order reaction kinetics. Here it is a second order reaction kinetics. Means what? Third, the rate is directly proportional to concentration of only substrate. Here the rate is directly proportional to concentration of substrate as well as the concentration of nucleophile. Fourth, the ease of SN1 reactions and the ease of SN2 reactions. Who is easily undergoing SN1? Tertiary alkyl halides are very easily undergoing SN1, followed by secondary, followed by primary. And here the ease will be primary alkyl halides will be very easily undergoing SN2 than secondary, than tertiary. For secondary, polar solvents will favor SN1 reaction mechanism. Why? Because they will make the carbonium ion in the first step, which is very easy to attack by the nucleophile. So it will favor SN1 reaction, and here non-polar solvents will favor SN2 reaction mechanism. So this is some basic differences. Can you find out any other difference? We have studied basic ones, we have studied the ease, we have also studied the solvents. Okay, so I think I have covered all the basic differences between SN1 and SN2. Now I hope it is clear to you. Now I will just go back and quickly we will revise कि substitution reactions are the reactions in which atom or group of atom is replaced by another atom or group of atom. Second thing, substitution reactions can be initiated by a nucleophile or electrophile or free radical. When they are initiated by a nucleophile, they will be referred as nucleophilic substitution. Nucleophilic substitution reactions are of two types, SN1 and SN2. SN1 is unimolecular, SN2 is bimolecular. Unimolecular means rate depends on only one substrate. Here rate depends on substrate as well as nucleophile. SN1 is a two-step reaction. SN2 is a one-step process. SN1 example is hydrolysis of tertiary butyl bromide using aqueous NaOH. SN2 hydrolysis of methyl bromide using aqueous NaOH. SN1 is a two-step process where in first step ion will be formed. A carbonium ion will be formed which will be attacked by the nucleophile. And one more point we can write, in SN1 there is 50% inversion and 50% retention of configuration. But under SN2 there will be 100% inversion of configuration, also called as Walden inversion. Okay, so this is SN1, this is SN2. In case of secondary alkyl halides, solvents will play a major role. If ionizing or polar solvents are present, they will make ionization of substrate, leading to SN1 reaction mechanism. If non-polar solvents are present, then SN2 reaction mechanism will be predominated. So this is all about SN1 and SN2 reaction mechanisms. I hope you have understood this, because this is very important not only for your exams but in general to understand the organic chemistry better. Your understanding of mechanisms should be very good. So please go through it. If you don't understand, watch the video one more time, and I strongly encourage you, please share this video with your friends, at least one friend of yours. It will be sufficient, and please ask them also to subscribe to my channel. It will mean a lot to me. Thank you so much for watching. Keep watching Be Pharmawise. Stay safe, stay home. Bye.